Muscle atrophy is the loss of skeletal muscle tissue, and the loss of muscle tissue makes you, of course, less capable of moving around, so your functional capacity is impaired, and it also has a major effect on your metabolic health. And of course, with the aging of our society, the loss of muscle mass is very prominent. So preventing muscle loss is an important factor to maintain proper health.
So our lab is currently looking for strategies that we can apply to preserve muscle mass during short-term immobilization. We've tried a number of interventions, including neuromuscular electrostimulation, which does seem to preserve muscle mass. We've also tested a number of nutritional interventions, which at this point have not been successful, but we're still looking for nutritional components which may successfully preserve muscle mass.
Muscle atrophy is a problem that we all suffer from. So at the very beginning of the project, we wanted to understand the reason why this problem remains an unmet medical need. Why aren't there other products on the market that can address this? And we realized that muscle atrophy is a multifaceted problem. And a lot of the approaches that were done so far were going after one target to reduce atrophy. So at the very beginning of the project, we decided to create a peptide network, so a multitude of peptides that can actually target that multifaceted angle for muscle atrophy. And after about a year work in this area, we identified a network of peptides that can significantly reduce atrophy. We tested it in vitro initially, and then we tested it in vivo with some significant results. This now is being embarked on a very interesting clinical with Professor Van Loon, where we're going to look at specifically atrophy due to immobilization.
It's very interesting if you can actually define certain peptides, maybe bioactive peptides, that have strong capacity to inhibit proteolysis or stimulate protein synthesis. And those peptides might play a role, or might be used to play a role in preservation of muscle mass in patients or in people that are temporarily immobilized.
Our technology searches through billions of molecules in food to find bioactive peptides. And we don't stop there. The technology allows us to unlock these molecules so that we can create a natural peptide network to maintain the balance between protein synthesis and degradation in muscle. An imbalance can lead to muscle loss. In our lab, we assess biomarkers that are involved in both protein synthesis and protein loss in muscle. For example, we look at the phosphorylation state of S6 downstream of the insulin pathway that leads to protein synthesis.
What's really amazing about our approach is the fast turnaround, as most discoveries of this type can take years. So we have scientifically validated the active natural peptide network in vitro and in vivo, and we are now ready to move to an exciting human clinical trial with Professor Loon.
Success of this project will be a successful preservation of muscle mass during a short-term immobilization period, or an enhancement of muscle mass during a recovery phase following immobilization.
We're really excited to start this collaboration with Van Loon, because the results of this clinical are massive for humankind in terms of how an AI system can discover a multi-network of peptides and how this can actually transform human health.
If we could find effective nutritional interventions to preserve muscle mass during immobilization or other conditions of disuse, we would have a strategy to support healthy aging. For those older people that want to maintain muscle mass, improve metabolic health, and remain active in life.